My dear friend, in today's video I want to start another video lecture that is very important topic in control system engineering, that is the feedback in control system engineering and its effects. So today's topic is the feedback and its effect in control system engineering. So already I have derived the transfer function of a closed loop control system and transfer function of an open loop control system. Therefore, now I will discuss about feedback, that is the role of feedback in control system engineering. To understand the higher order control system or modern control system engineering, we should know about the role of feedback and in its importance in control system engineering. Therefore, to understand modern control system, so first we should understand thoroughly about the feedback and how it affects on the system performance, error, etc. We should understand that thoroughly. Therefore, let us discuss about the feedback and its effects in control system engineering. So, feedback plays an important role in the control system engineering. It reduces error and also it reduces the sensitivity to parameter variations in control system engineering. So in today's topic I will discuss what is called feedback. So in today's topic I will discuss what is a feedback, and the second is what is control system parameter and its variations. So first I will discuss about the feedback. So let us discuss about what is called a feedback. That is called a feedback. So feedback is nothing but it is a transducer which converts energy from one form to another form, and in some cases it is the output signal itself fed to the input that acts as the feedback signal. So let us discuss, or let us understand the feedback details by taking some examples. So it is a transducer which converts energy from one form to desired form. So here one form to desired form means that is according to reference signal, the feedback transducer converts the output or controlled signal to the reference signal or to match the reference signal. For example, if the reference input signal is an electrical voltage, then we have to connect a transducer which can convert output signal to electrical voltage. Similarly, if the reference signal is the temperature, so we have to connect one transducer which can able to convert the output signal to temperature. That we can understand by taking some examples. So now let us discuss. So generally this feedback connected in between output and input. So sometimes this is also called output sensor or feedback sensor. The feedback sensor is connected to the output or controlled output, and that converts the controlled output to match the reference input. So it feedback a signal which is called feedback signal, that is fed to the comparator circuit, and comparator circuit compares the reference input and feedback signal and produces an error signal which is fed to the power amplifier, and power amplifier amplified that signal and fed to the actuator, and actuator changes the process input, and the processor produces the desired output or controlled output. So to understand this, let us take one example of position control system, that is let us एक one example of DC position control system. DC position control system. So this is the potentiometer. This is angular position setting. This is nothing but our reference input. So this is goes to comparator circuit with power amplifier, goes to DC servo motor, goes to shaft. And this is the taco generator. So this is your DC position control system, that is to position a object in a particular angle. So DC position control system is used. So this is the reference input, that is angular position setting. For example, if we go to our control system lab, we can find out the DC position control system. There is a knob. By adjusting that knob, we can set the particular angular position, that is 120 degree, or it may be 60 degree, 30 degree, or any angular position we can set. So then what happens, it is directly connected to a potentiometer that converts this angular position setting to electrical voltage. This is the electrical voltage. This is electrical voltage, and here the feedback sensor, or this is called transducer, used is called taco generator, which converts the controlled variable. This is our controlled variable, that is actual angular position. This is the actual angular position. So the taco generator converts the actual angular position to electrical voltage. So here feedback signal is electrical voltage. So it is fed to the comparator input, and this is the reference input. Both are electrical voltage. Therefore comparator compares the reference input according to our angular position setting or command input and produces one error signal, that is your error voltage. Here the power amplifier act as a controller and DC servo motor act as an actuator and the shaft act as the plant. So this error voltage feed to the power amplifier and power amplifier amplifies this error voltage and feed to the DC servo motor, and DC servo motor according to error produced it starts rotating and accordingly the shaft also starts rotating. Therefore this angular velocity converted to electrical voltage and compares with the reference voltage. So when error voltage will be 0, then we can find out our desired output according to angular position setting, that is 120 degree or 60 degree or 30 degree, etc. Therefore here tacho generator act as a feedback sensor or feedback transducer. So therefore due to feedback the error is automatically corrected here, that is up to there is an error it starts rotating. When error voltage is 0, it comes to equilibrium position or steady state position according to our reference input or command input. So to understand the feedback we can take another example, that is our automatic iron. So let us take another example, that is automatic iron. So this is our automatic iron system. Here the temperature setting, this is our reference input and this is the thermostat and this is our switch and heating element and this is the iron plate and this is the feedback, it goes to thermostat and this is the actual temperature. So this is another example of feedback system, that is our automatic iron. In case of automatic iron, what happens? We have adjust the temperature setting according to our dress, that is it may be cotton, rayon, nylon, etc. So accordingly we will set the temperature by one knob. So that is the reference input and that is goes to directly measured by the thermostat, and the thermostat produces a control signal. It produces one control signal which fed to the switch and heating element. So gradually, when our actual temperature is produced by the controlled output, then the switch is open and the iron plate is not heated, but due to heat loss, this is the heat loss, due to heat loss, so when temperature gradually decreases, then what happens, the here switch, that is thermostat, sends one control signal to switch and heating element, and the switch is closed. Then again the iron plate starts heated up to get our desired temperature, up to get our desired temperature. So here the reference input is the temperature, and the output, controlled output, also temperature. Therefore here no need to use any transducer, because here the reference input and the feedback signal both are matches with each other. Therefore this is another important example of feedback. So therefore the feedback automatically corrects the error in the controlled output or our desired output. Therefore it is plays an important role in the control system, and mostly control system uses the negative feedback system. In the rare control system, the positive feedback signal is used. That I will discuss in my next lecture, but now we should understand what is called control parameter and its variations. So first we should know what is called control parameter and sensitivity to variations in control parameter. That I will discuss afterward. Now we should know what is called control parameter. So control parameters are nothing but that is control output or control variable depends on certain parameters. For example, in case of speed control of DC motor, the speed control of DC motor is done using two methods, that is our armature control method and field control method. In this case, the control parameter depend upon armature current and field current. So alternately the field current also depend upon the armature resistance and field resistance, and field resistance also armature resistance depend upon temperature. So when the motor starts running, the temperature gradually increases, but during the stop condition, it means when the motor is in idle condition, the temperature is low, therefore resistance also low. But when the motor starts rotating or starts running, the temperature increases, so resistance also increases, because already we know that the conductor uh, depends upon the resistance of a conductor depends upon temperature. So it is having the positive temperature coefficient of resistance. That is, when temperature increases, resistance increases. When temperature decreases, and resistance also decreases. Therefore, here the control parameters are nothing but the armature current, field current, then field resistance, armature resistance, then temperature. So it means the controlled output depends upon certain parameters. Those are called controlled parameters. The controlled output depends upon certain parameters are called controlled parameter. Control parameter. So in case of DC speed control, so control parameters are resistance, temperature, armature current, field current, etc. Therefore, when it starts running, the control parameters changes, that is, the resistance changes. Another case, we can take the PMMC instrument, that is permanent magnet moving coil instrument. So that is very sensitive to temperature, that is the spring of the that is control spring is sensitive to temperature. Therefore, when temperature changes, the resistance of the control spring changes and the current also changes. Therefore, it produces one error in PMMC instrument. For example, if you will use one PMMC instrument in one place, if you will take that PMMC instrument to other place, like one hot place where temperature is high, the resistance automatically increases due to temperature. Therefore, it produces error. So to reduce this error, the feedback plays an important role, that it reduces the sensitivity of parameter variations in control system engineering. That I will discuss later details. So in my next lecture, I will discuss each and every effect of feedback step by step. So thank you very much.